Hello everyone, welcome back to ptet.chemistry channel. So in this continuation video of these kind of topical MCQs, this is on my classification of topic 1, which is just on mole calculations and stoichiometric concept. So in this question, so we have leaded petrol, where we have an additive composed of lead, carbon and hydrogen. So this compound contains 29.7% of carbon, this much percentage of hydrogen by mass, and we know that it has lead, carbon and hydrogen. They give us the percentage of carbon, they give us the percentage of hydrogen, therefore the percentage of lead would be equal to the difference taken away from 100%. So the percentage of lead will be 100 minus the percentage for carbon and the percentage for hydrogen. So be very careful of your use of bracket because it's very easy to make mistakes like that. So what next? So yeah, this is basically a calculations or empirical formula. So if you set up lead, carbon and hydrogen, so I will have percentage by mass. Then this is 29, oh sorry, lead is 64.11, carbon would be 29.7%, and hydrogen is 6.19. And if I want the mole, so mole is going to be the mass divided by the relative atomic mass. So have a look at your periodic table. I'm just trying to find where my periodic table is. Okay, so my periodic table shows lead as being 207.2, and then there's 29.7 divided by 12.0, 6.19 over 1.0. So you can pop that into your calculator, and I get 3094. I mean, with a lot of numbers that follows after that, but I guess I don't need that too many significant figure, and anything divided by 1 is just 1. And then of course we just get the simplest ratio of the atoms because we are looking at empirical formula, for which the definition of empirical formula is the simplest ratio of atoms in the compound. So the smallest number is this. To get the simplest ratio, we divide each of these by the smallest number of the mole, so that is divided by 0.03094. that gives you 1 because it's divided by itself. And I can roughly see this being 8 because 8 times 0.3 is around 2.4. But anyway, let me just double check. It is indeed 8. It's 7.999, which can run up to 8. 6.19 divided by that should give me roughly 20, give or take, and it is indeed 20.0. So looking at the formula given is PbC8Hx. so the empirical formula, definition of which is part of your syllabus here as chemistry. So X, which is the number of hydrogen atoms in the empirical formula, is just 20, which is one of the options being given there. In this next question, we have ethyl ethanoate, which is an ester from your IGCSE or O-level. It's usually the last bit of your syllabus from your 14 to 16 years old chemistry curriculum. So the ethyl ethanoate refers to this thing here, and you will know that well, you should know how to draw them because you have done those IGCSE or GCSE or O-level chemistry before you come to A-level. So be very careful if you think you know a lot of things, but if you actually don't know a lot of things, then it's worth it for you to revisit those concepts, because it's very dangerous to continue doing A-level chemistry if you are not competent enough. Right, so what actually happened is that the carboxylic acid loses the OH and the alcohol loses the H, and you get this ester linkage as a result of condensation reaction, something you cover more in A-level organic chemistry as one type of general organic reaction. Anyway, this question is not really about the organic chemistry, it's more about calculations, mole calculations, hence it's in this classification. So you have 30 gram of ethanol, 30 gram of ethanoic acid, you reflux them together and you get 22 gram of ethyl ethanoate. So this is the actual yield of the ester, and you want to know how much is this percentage yield. Is this 100% of what you expect, or is this like less than 100% of what you expect? All right, so based on this 30 gram 30 gram, these are masses, and when we are dealing with balance equation like this, these are expressed in mole ratios, so we have to resort to using mole. So I have to first calculate the mole of ethanol. Ethanol is the CH3CH2OH, so 12.0 plus 3.0 times, I can just use the molecular formula, I guess, C2H6O, C2H34O2, C4H3458O2. Alright, so 12 times 2 plus 6 plus 16, that give me 46.0. Of course, your calculator doesn't show you the 0.0, but you know, what was I gonna say? Your predictor table does show you to one decimal place, right? So 12.0 times 2 plus 4 times 1.0 plus 16.0 times 2. I have 60.0. So that is for the carboxylic acid, and then the molecular mass for the ester is 12.0 times 4 plus 8.0 times 8 times 1.0 plus 16.0 times 2. I have 88.0. Is that correct? Yep, that sounds right. Yep. So what happened next is I have to work out that, you know, which one is completely reacted. Okay, or are they both in the same exact ratio, because 1 mole of this react with 1 mole of this. So I have to work out the mole of ethanol that actually reacted. So that is 30 gram mass over the MR. So 30 divided by 46.0 give me 0.65217, etc, etc. But I think 5 significant figures should be enough for now. So I'm looking at the ethanoic acid now. So the ethanoic acid, the mass is also given as 30 gram divided by 60.0. That gives me a very nice number of 0.5 or 0.500 as you wish. So now you can see 1 mole reacts with 1 mole. Here you don't have equal mole that reacted. So one of them is in excess and one of them is limiting. So 1 mole of ethanoic acid reacts with 1 mole of ethanol. 0.5 mole of ethanoic acid would only react with 0.5 mole of ethanol. So based on that reasoning, which you could be asked in, you know, theory paper, therefore, since this is greater than 0.50 mole, and because the mole ratio is 1:1, therefore ethanol is in excess. All right. So since 0.5 mole of ethanoic acid only requires 0.5 mole, should probably write that a lot better, 0.5 mole of ethanol. Therefore, the ethanol, the actual amount of ethanol used, which is 0.65, greater than 0.5, is in excess. So ethanoic acid is the limiting reactant, and when you do calculations, mole calculation, you have to use whatever is completely used up, which is the limiting reactant completely used up, and not the excess reactant, because not all of it is reacted. So I want to find the mole of the ester relative to the mole of whatever is completely used up, which in this case is the ethanoic acid that's completely used up. So I have to relate the mole ratio of the ethanoic acid completely used up, the limiting reactant, with the ester. It's still 1:1. So the mole of the ester is equal to the mole of the limiting reactant, which is the CH3CO2H, the acid. So I work out the mole of the acid being 0.5 already just now. And then I want to know the mass of the ester that actually formed. So mole of ester is mass of ester divided by the molar mass of ester, which I had calculated earlier on, which is 88.0. So the mass of the ester that actually form, this is theoretical, okay, theoretical, because this is assuming 100% reaction. When you assume 100% reaction, 1 mole of this react with 1 mole of this to give you 1 mole of this and 1 mole of this, but this is what you actually get. So our job is to find out what is the theoretical mass, bring this up there, and you can get 0.5 times 88.0, and you will get 44 gram. So out of this 44 gram that we expect to get, we only actually obtain 22 gram. So that is very clearly half of it. So the percentage yield of the ester is how much we actually obtain divided by how much we expect to obtain from 100% reaction, and that give me 50% exactly. So that's just the answer C there. In this next question, so we have an equation being given here. This is a household bleach that contains the sodium chloride 1. The concentration of this bleach, the concentration of this ClO minus or NaClO in the bleach can be determined by reacting with an aqueous hydrogen peroxide. Hydrogen peroxide is H2O2. You will have learned that the oxidation number of oxygen is always -2, except when you have peroxide, then the oxygen is actually -1, and you have 2 of them, so altogether 2 times -1 is -2. The hydrogen remain +1, times 2 is +2, -2, overall the compound has no charge, okay, or overall oxidation number is just 0. So the bleach itself is this thing here. So the equation is already balanced. You are asked to find the concentration of the NaClO. So again, I will set up my mole calculations equation like this. I could set it up using mole ratio, as you have seen me doing in a lot of my other tutorial videos like this, as 1/1. But then I could also see that they are 1-to-1, so I could very easily set them up side by side like this to simplify my bookkeeping. Alright, so 25.0 cm cube of the bleach, I would need to convert to dm cube by dividing by 1000 or multiplying by 10 to the -3. And then I multiply by concentration. Concentration, I write the species, and then I write square bracket to represent concentration. This will make more sense once you go to equilibrium, where we always represent concentration as the species itself in a proper square bracket. So that concentration is in mole per dm cube times dm cube give me mole, which is the unit on the left hand side as I've shown in this expression here. Same thing goes for this. Oh, actually, I don't want hydrogen peroxide because I should have read the question. It's actually the mole of oxygen gas that is produced, and luckily the mole of oxygen gas is 1:1 compared to that. So I'll skip that out. I will rub that out. This is actually the oxygen gas that I am comparing the mole ratio with, right? But the oxygen gas is being given off as a gas. So this is a gas, and it's a bit lucky and direct that the question give you the mole, because when they give you the oxygen gas, the volume of a gas is not the same as volume of a solution. So the mole of oxygen is 0.0350, and it is still 1 mole obtained from 1 mole of the bleach. All right, so this is basically about bookkeeping and seeing if you could do your simple mole stoichiometry calculation. Actually, maybe I'll put it down there. 0.0350 divided by 25.0 times 10 to the -3, I get 1.4 mole per dm cube. You see that your calculator give you 1.4. The data given to you was in 3 significant figure, 1, 2, 3, 1, 2, 3. So if you are seeing this on calculator, you should have put 1.40 to be appropriate number of significant figure as required by practice throughout your, I don't know, your A-level sciences. Is all about appropriate number of significant figure to show the accuracy of your calculations. Yeah, okay. Next question. So seems like this is just a balancing equation kind of question, but let's just read through the question. So in firework, there's a reaction between powdered aluminium and powdered barium nitrate, in which you give off some heat. So the reaction is exothermic, as you would have learned from your GCSE or O-level or IGCSE. Exothermic reactions give out heat, and you produce an unreactive gas. So this is the important information here. NO is a reactive gas. Oxygen is a reactive gas in the sense that it promotes the combustion for more substances. We are looking at things like nitrogen, which are totally unreactive. It's very difficult to react nitrogen gas because of the strong triple bonds that need to be broken before the nitrogen can actually react. So I can cross out A and B. What about C and D? Looking at the product and the reactants is aluminium and barium nitrate. Both the formula are correct. Pa2 plus NO3 minus. So the LCM, or lowest common multiple, means that you need 2 of the anions to balance out the Pa2 plus. Here you produce the Al2O3. Here you produce aluminium nitrate. Both of these produce barium oxide and nitrogen gas. So if I'm looking at it, it looks like, is it really a balancing equation? Maybe it is. Let me see if the equations are balanced first. 10 aluminium, 10 aluminium, 3 barium, 3 barium, 2 nitrogen times 3 is 6 nitrogen, 6 nitrogen. Oxygen is 6 times 3 is 18, 5 times 3 is 15, plus 3 is 18. 10 aluminium, 10 aluminium. 18 times 2 is, 18 times 2 give me 36 nitrogen, 3 nitrogen, 30 nitrogen, plus 6 nitrogen. So nitrogen is balanced. Seems like both equations are balanced, so I need to decide, well, we need to decide what's going to happen. All right, so the other thing is about this exotomicity of the reaction. So when you are forming aluminium nitrate, you have the attraction between Al3 plus and NO3 minus, 3 of them, versus Al3 plus and O2 minus. You have 2 of these and you have 3 of these. All right, so this is a much smaller anion than this, because this consists of 4 atoms. This consists of only 1 atom forming the ion, and this is going to be a much stronger ionic bond, much stronger ionic interaction, something you would have learned from your GCSE or IGCSE or O-level chemistry as part of your electrolysis of aluminium oxide, where you now require so much energy for that reaction, for the electrolysis to happen. That's why we needed to add cryolite to help to lower the very high melting point of these, right? Whereas this would be ionic, but it would have a slightly lower ionic character, and as a result a much lower melting point than this. My point is that this is a weaker ionic bond being formed, and this is a stronger ionic bond being formed, and I would expect between the choice of C and D, given the question, I would go for option C rather than option D. Alright, what else can help me to do to break down that concept? Not much really, I guess. Yeah, there isn't really much that I can do to help break down the concept into that. There's also a bit of group 2 chemistry involved as well, as you will learn about group 2 nitrate when you reach top periodicity much later on, that you will know that group 2 nitrate can give you the what am I saying, the resulting products as well. All right, but not necessarily, I guess. Yeah, okay, I'll probably go for C. Okay, this is the last bit, this is the last question on this 5-question series. So a lot of calculations, they tend to be quite long, yeah. So I spent a bit longer on this, but in reality, in an exam, you probably have only 1 or 2 minutes to break down the questions, and it doesn't get easier unless you have some practice, not with familiarizing with questions or memorizing questions, but thinking about how to approach a question is very important. So here you have a hydrocarbon. So a hydrocarbon meaning a compound containing carbon atoms and hydrogen atoms only. complete combustion of a hydrocarbon, you should know the general equation, which I have shown in my other tutorial videos, specifically on tackling reacting volume of gases under topic 1 topical playlist as well. So you get XCO2 and you get Y/2H2O. This is algebra expressions, and they do balance out if you do the algebra correctly. Okay. What else? I have 0.200 mole of hydrocarbon. I know I get 35.2 gram of carbon dioxide, and I know I get 14.4 gram. So the mole of CO2 is going to be the mass divided by the MR, which is 44.0. If you do 12.0 plus 16.0 times 2, that is what you would get. And I get 0.8 mole. And the mole of H2O, because I'm given the mass, that is the mass divided by the MR of H2O. So 1.0 times 2 plus 16.0, that will give you 18.0. That also gives me 0.8 mole. So what I can do now, what I can do now is I can simplify the mole ratio. To compare the mole ratio to get the value of X and the Y, which we need to work out the molecular formula of the hydrocarbon, which is CXHY. This is 0.200 mole. I need to make it into 1 mole, because in this equation, this number here is 1. So what I'm going to do, because this is mole, and mole, I would divide by the simplest ratio for this number here, because I want to get 1 in front. Because I do that on the left, I have to do the same thing on the right. So if I do that, so I'm just comparing mole ratio, I get 1, I get 4, and I get 4. So from this balance equation, this is 1 mole now. So X is equal to 4 and Y/2 is equal to 4 as well. Alright, so therefore X is equal to 4, therefore Y/2 equal to 4, Y is equal to 8. And you want the molecular formula. The molecular formula is CXHY and is C4H8, and this makes sense to be CnH2n, which is a typical general formula for a straight chain, for an unbranched, for an alkene in general, CnH2n, yeah, something you have learned from GCSE or IGCSE or O-level. So that's the end of this 5-question series of mole calculations and stoichiometry. A bit longer than the usual 5-question series because this involves calculations. And if you enjoyed this tutorial video, make sure you click the button at the bottom right, subscribe to the channel, share the channel with friends, your social network, your various chat group, your juniors, seniors from school, and check out my other creator playlists, my other topical playlists before you actually jump onto a real exam paper. Before you are ready, it's actually self-destructive. Alright, so thank you for watching, and I'll see you in the next video.